Hello everybody. In this video I'll be talking about my project for CAC 555. My topic is computing the fatness of a polygon. So the problem is, given a polygonal shape, we have to quantify how fat or nice the polygon is by the means of a scoring function. We would ideally want polygons that are disk-like to have the maximal fatness values, and we want skinny polygons to have low fatness scores. So the polygon on the left is fatter or nicer than the polygon on the right. The approach we take is, given an input polygon, discretize the boundary by introducing additional points on the boundary. For each point, original plus the ones we added, center a disk of increasing radius until all the points are covered in the disk, and calculate the ratio of area of intersection of disk with polygon to the area of the disk. The minimum over all values of radii and all points is the fatness score. So let's see an interactive demo. So now I can just draw a famous polygon we all know from the chapter on guarding. I'll just mouse in the points. Okay, so this step just adds the extra points, and now this search over all the points and all the values of radius. My code can be run as a user input, which I just did, or as a text file input. You can turn the animation on or off using a flag, and here we see the fatness scores. Now we see results on some synthetic data. First up is this roundish polygon that has a high score. This pentagon is less round than the previous example, as we can see. The star-shaped polygon is not fat, and the score reflects that. Even skinnier is this snake-shaped polygon. And let's not forget our favorite polygon. The objective of this project was not to run this program on synthetic data, but to run it on actual election districts and get a measure of their fatness. So I took the map data of 5,800 plus election districts in New York City and ran my code on all of those polygons. So here is the web page that I created. It is hosted on my GitHub. It's live right now. It has all the election districts of NYC, and you just have to click on a district and get the fatness value for that district. So you can click anywhere on this map and get the fatness value. So the reason I made this visualization was that it gives me all my data on one page, and I can choose what I want to see and what I don't want to see. And it basically allows me to actually play with the data. I can just zoom into this area. I see this roundish figure, so let me find out. So the value of this is 0.18, so it's a pretty high value. Now let me compare and contrast this with something else. For example, this thing, this block here, they're connected by a narrow path. Let's see. And the value is 0.07. Let's see what this one is. It's also 0.08 because it has these tentacles coming out. It's a skinny polygon. This one is round, but it's not as round as this one. This island has a pretty large value too. And we can just do this for any location in the map. We can see these big districts over here. Their values are pretty good because this is not so skinny. This is skinnier. And we can just do it for any place. This also allows us to see it gives us a global perspective, because we can see that in this region of New York City, most of the districts here are squarish or rectangle-ish, something like that. So we can just see these values are pretty good. All of these are rectangle squares, something like that. However, if we go to some other area of the map, say this one, everything here looks like a jigsaw puzzle, because you can see everything is pretty zigzag, everything is stretched out. Just look at this district. So the values here are pretty small, and you can just eyeball it too. So I think this is an application of this project. We have the backend Python logic which utilizes computational geometry, and we can just render it. We can render that data in this map, and we can get insights using this. So if someone has to split these districts and make new ones, he can just eyeball it. He can just find out that, okay, these are the bad ones, and we can just improve them. So this is some real data, but I've already showed you the best results already. Like you can see everything on the map. This is just for, and here's the technology stack and the resources which I'm using. So most of the core logic is in Python. It uses matplotlib, argparse, numpy, math, and JSON. And for JavaScript and for the web development part, I use JavaScript. I use the D3 library. It's a very flexible library, and I use HTML and CSS for the basic web page. Also, thanks to NYC Open Data, that's where I got the map coordinates from. Thank you.